Okay, so these.
So why do you give us so many?
Or would you rather write it down? I've given you 3. I gave you 3. Okay. Folks, please. Alright, so this, I'm going to draw back and we get out of the way. These are the names that we need to become familiar with. You'll see the names here in your regular polygons. So we're just going to do regular polygons right now, which have all the same sides and angles. Septagon 7. Alright. So you're looking at this type of picture right now. Now that you have the sum of the interior angles of any polygon, you can use that information to find the sum of the exterior angles in any polygon. Fill in the following table. Yes or no? Okay, so we want to find a pattern relating the number of sides of a polygon and the number of degrees in the exterior angle. Now, what's different about these pictures than the ones you've seen before this? What makes these ones just a little bit different? I got a little extra lines. So what I want you guys to realize is that's the exterior angle. Notice what they did. They took that triangle and they extended all the sides out a little bit. And so now your exterior angle is that piece, or that piece. The exterior angle of this rectangle is that angle, that angle, that angle, that angle. So they're found by extending the side with like a ruler and comparing it. Okay, so these are your exterior angles. Exterior like a house. So let's begin just to fill this in with the knowledge that we learned today. If I have a regular polygon of a triangle, so that would be an equilateral, what's the total number of degrees in the interior part of the angle? 180. 180. What's the number of angles? 3. And now remember, this is a regular polygon. So what's the degree measure of one interior angle? 90. One interior angle of a 60. 60. So if you really want 180 divided by 3 equals 60. Now it says the number of degrees in one exterior angle. And let's go back one slide so we can look at this. If this is 60 degrees here, how big is that exterior angle? Laurice, can you hold off a second, please? 120. How did you guys get that? These two things have to equal up to 180. Because it's on that straight line. It's right on a straight line. Does anyone remember what kind of angles we call those two?
Straight.
These two. Does anyone remember what?
Supplementary.
Supplementary. Beautiful. Thanks, sir. Okay, so that's supplementary.
Oh yeah.
Oh yeah. All right. So they add up to 180. And the number of degrees in one exterior angle is 120. What's the total number of degrees in all the exterior angles? Remember, they're all the same. What's the total number? So I would take 3 times 120 and I get... Alright, does that bother anyone? Okay, a quadrilateral. Remember, we're working with like a square or a rectangle right now. Quadrilateral. Total number of degrees in one interior angle.
360.
Total number of degrees in one interior angle. 90. Alright, so if that's 90, what's the total number of degrees in all of them? Or what's the total number of degrees in one exterior angle? If I'm looking at this thing, this is a 90-degree angle. How much is here?
270.
It's still a straight line, so how many degrees? So a total number of degrees has got to be 180. That means that has to be 90, because 90 plus 90 is 180. So if this is 90 degrees, what's the total number of degrees in all the exterior angles? 360. So I took 4 90s, and I made 360. Does this bother anyone? No? Let's go back to this question though. You told me that a 10-sided shape should have more interior or exterior angles sum-wise than a quadrilateral. You said that that would be a bigger number. But if I go back to my table, they're already matching. What do you think happens with a 5-sided shape? It'll end up being 360. Let's try it. A pentagon. Number of degrees in the interior angles. This is the last one we're going to get to. 540.
Mr. Guys, I noticed how did you get more sides or exterior angles?
Yeah. Number of degrees in one interior angle. 108. Okay. Number of degrees in one exterior angle. And remember, these are all the same because of this key word right here, regular. 72. 5 times 72? Okay. Try and finish that up. You have your homeworks. Yeah, no. Just the one. We'll finish this up tomorrow because there's a back to it. We'll answer those questions and we'll move on. Should be quick.
I do that.
Where? When?
For what reason?
You got homework.
I cut them off.
No, we don't.
You're like 18.
Right?
I'm not going to talk about it today.
What?
I have like a 6.
128.
Okay. Let's put the calculators away. Can we please get all the protractors and my Four, at least in pencil. But it's not possible because I purchased about 130.
How you know?
So buying the packing 24, I've gone through 5 or 6 packs of that, and then 5 or 6 packs of these. Okay, folks, let's go. Protractors, you have your homework. Do not lose the sheet from today. Great. You tell them. Because her grade went from a 98 to like not 90 anymore. Because she doesn't do her homework as much anymore. Because she doesn't ask good questions anymore. She sits back there in mediocrity.
my god.
Compared to what?
I don't know the guy. What's homework?
Good. Trying to get tired. Staying up, talking on the cell phone. Alright, I don't have all my pencils. Can I please get them back?
I just resigned up.
Protractors, folks. Oh
I get on it like once a day. Not even.
Kuspa, they expect you to do it all, don't they? It's not very helpful.
I'm varsity. You guys are JV. You guys are JV.
No, you're gonna do track, right?
Oh, yeah.
Yeah.
How do you know?
Because I just know. Because track's better.
Do you think this was not that right?
No. Don't let anyone.
Track is not good.
Yeah.
Track is awesome.
No.
When you run, you get in shape for your other sports. When you play baseball, you swing a big stick.